We are very excited to announce that GRBL is now fully functional with RapidChange ATC and GSender. GSender is a free open source G-code sending software available by CNC Labs. The workflow is very easy, and I'm going to go over that now. I've got my GRBL machine hooked up and will connect to the machine. Now let's go ahead and home it. Now I'm going to do a command line command and send it to the G28 position, which I use as a parking position, and it's a good idea to set it up. Now, there's a few components involved with getting this to work on the GRBL board, and we're going to go up into settings and the little gear icon up here in the upper right. We're going to come down to tool change. This bit of code gets pasted into the before change code, and we have the after change code that actually performs the M6 tool change. That gets pasted into here. Make sure that your pass-through is turned off. Close that. Then I've got a macro here, which is initialize RC settings. I'm going to open it up in the editor. All the variables for your particular machine will get entered here. This is a copy of this macro that I have written comments on to explain all the various parts. For the pocket offset, you can follow this link and it will give the different pocket offsets for different size collet nuts. This is a ER11, so it uses a pocket offset of 38. All the rest of the variables get entered down in through here, and you can do that in Visual Studio Code, or you can do it right here in the editor. Everything below this line is part of the code and doesn't need to be messed with. So what the workflow involves on startup or a hard reboot, running this initialize RC settings macro. I'm going to pop out the console so you can see how that goes here, and we'll simply run that. It's spitting out all these messages because this one particular macro has all the comments explaining the meanings of all the values. The next step is to set the tool in the spindle. When it starts up, GRBL is not going to know, or GSender is not going to know which tool is in the spindle. So it's very simple. Enter into the command line. We actually have tool 1 in the spindle right now, so we want to enter T1, hit enter, and then we're going to hit this icon, set tool in spindle, and that will set the current tool to tool 1. If you ever want to know what the current tool in the spindle is, you can type in $G, and it will give you, spit out this line of code, and we see here that tool 1 is recognized as the tool in the spindle. Now I've already got everything set up on my machine, and the information is on the website as to how to find pocket 1 and the Z engage height. So in order to change tools, most of the integrations that we have done, you can simply enter M6T, whatever tool you want, and it will go pick the tool. GRBL is a strange animal. It's very basic. Thanks to GSender, we were able to script in everything we need to make the tool change. But you can't simply write a macro to make a tool change, nor can you just enter an M6T number into the MIDI. So what you have to do is load a file, and we have these files available. It's a simple file, and so we're going to go ahead and change to tool 2. Tool 1 is in the spindle. We're going to load we want tool 2, so we're going to load the tool 2 G-code file and simply run it. Now I'll show you this. Whenever a tool change is made through G-Sender, you have to confirm the tool change. This could change in the future, but this is not something that we are able to do on our own. So you confirm the tool change. The spindle is going to move over, drop off tool 1, pick up tool 2, and set the tool length offset for tool 2. So we'll do that now. Takes a second for the code to run. It's pretty simple. Now I have tool recognition set up with our IR sensors, and the fascinating thing that we found was that by probing away from the switch, we can use the probe to actually check to see whether a tool has been loaded or unloaded properly. So the tool setter, I also have a touch plate and a 3D probe that we'll use here in a minute to find our part, are all wired to the same pin. So the IR sensor, which is a normally open, pulls to ground when it's triggered, just like the tool setter and the 3D probe and your conductive touch plate, all wired to the same pin, which is very convenient. And I'm going to go ahead and show you their probing routine too, because I think it's pretty cool. So we're going to close this, and what we're going to actually do is we're going to tell it to pick up tool 1, but we don't want tool 1 in the spindle. We actually want no tool in the spindle, because I'm going to load the 3D probe in the spindle so that we can probe our workpiece. There's no way to tell it to unload a tool at this time, but this workflow works pretty good. So let's go ahead and we'll bring our video back up. I'm going to make it a bit smaller so that you can see the message that pops up. And now we're simply going to load the tool 1 file and run that. So we get the confirm tool change pop up. Confirm the tool change. Dropping off tool 2. Now watch what happens when it goes to try to pick up 1 and there's no tool. Okay, well, I forgot to grab it out. So, okay, so let's do it right this time. Pull tool 2 out of the pocket. We're going to load the tool 2 file and start. Confirm the tool change. Drop in tool 1. Now watch what happens when it tries to pick up tool 2 and there's no tool. And we get a pop-up on the screen, M0 program pause, and that's because it failed to pick the tool with the tool recognition. So it's waiting for user input. If I had the console up right now, you would see the message that says that tool 2 failed to load. Please load it and hit cycle start to continue. But we're going to put the 3D probe in the spindle. Plug it in. Okay, now we have the probe in the spindle, and notice that the spindle came out from the magazine in Y 50 millimeters. I have that position set for my manual load position, and so we've manually loaded the tool setter in there, or the 3D probe, I'm sorry, and now we're going to hit resume and it will measure the probe. Okay, close that. Now, fix that. Now we have a measured probe, and you don't have to measure it every time because it's going to give you a tool length offset that can just be manually entered in every time you load the probe, but it may be not a bad idea to do it this way. So let's move it over and let's probe our piece. Alright, I think that's pretty good. Come over here to the probe window, and we're going to probe X, Y, and Z, and I'll show you how I've got this set up with the probe. I've got, this is a 2 millimeter ball on here. I've got the Z thickness is 0, X and Y thickness is 0 because we're going to touch off directly to our block. Close that. You can see I've got the 2 millimeter here, and we're going to click the probe button. Now it wants you to initialize, make sure that the probe is working. So we'll trigger that. Now we can start the probe. And our piece has been probed, our work set offsets have been set, and we're ready to cut. So let's move Z up with the G53 and remove the probe. Now the controller thinks we have tool 2 even though we have an empty spindle. We're going to go ahead and run it anyways because it's not going to hurt dropping off an empty spindle. And let's just double check with a $G, and yes, tool 2 is the tool in the spindle. So now we're going to load our test file. And I don't have the dust cover set up on this. G-Sender is going to pause between the tool changes. Like I said, there's no way around that right now, but it sure beats wrenches. So let's check it out. So here's my GRBL test NC file. We're going to open that. No, that's actually not the one I want. This is the one I want. There we go. Now I'm not going to cut all the way down through this piece for the sake of time. This file is going to use 3 tools and 4 tool changes. So, thinks tool 2 is in the spindle, so it's going to try to drop it off. We could do an extra step, but I can't change it to tool 0, so we're just going to run it like this. So let's go. Dropping off tool 2. That nut actually has some problems. I don't know why it fails to pick up sometimes. Or it picks up and then it thinks it's failed to pick up. But it only happens with that, and I think it's that clamping nut. It's kind of weird clamping nut too. I don't know if you can see this, but I don't think it's probably very balanced. Look at that chamfer on there. It's way higher than the other one. Kind of weird, but okay, so we'll hit resume. Now it's setting the tool length offset, which is separate from the work coordinate system, which is very nice because each subsequent tool change will find its place in Z, and you don't have to set your Z work coordinate every time you start or change a tool. Okay, we get our confirmed tool change pop up back up, but I'm going to take this time to vacuum everything off because, like I said, I don't have a dust cover set up on this yet. That one. Alright, confirmed tool change. Normally I wouldn't set the Z so high to measure the tool, but measuring the probe, it's pretty long. This is just going to come in and clean up the edges. Confirm the tool change. Confirm the tool change. Yep, that clamping nut has problems. Just running a little cleanup file, or tool path, I mean. back to my G28 position, and there you have it. GRBL and G sender, automated with RapidChange ATC. Get yours today and enjoy happy tool changes. Thanks for watching.